It's not uncommon for a business to determine a service level first, and then at that point need to figure out how to achieve that service level. That is to say, what reorder points should they use exactly to obtain that service level. That's what's going on in this particular scenario. Let's look. Okay, it says immediately, consider scenario 3A. Adventure Center's management believes that the service level when reordering any bottled beverage should be closer to 90%. Given this clarification, what should the reorder point be for water bottles? Oh, right, because it said consider scenario 3A. And in scenario 3A, they were looking at the reorder point for bottled water. And wait a minute, I'm recalling scenario 3A. Demand during lead time for bottled water varied. What were those numbers? They needed on average 1,500 bottles of water while they waited for a new order to arrive. And I'm just recalling scenario 3A. The standard deviation that described that degree of variation was 200. Oh, right, and we had actually been discussing earlier in scenario 3A that this bell-shaped curve normal distribution is believed to be a good enough characterization of the general variation that you do see in the demand for bottled water during lead time. Now, last time we had a reorder point, we were figuring out what the service level was. Notice this time we have a service level and we have to figure out what the reorder point is. Oh, okay. Now, just like last time, this line right here has meaning, because this is an illustration of a reorder point. Okay, if we reorder at this point, then right, this is why the paler part of the curve is labeled service level. This is all the different futures in which demand during lead time was less than the reorder point, so we did have enough, right? And this, unfortunately, over here, what's excluded to the right is all of those futures in which demand for bottled water exceeded supply during lead time and we stocked out. Oh, okay. Now, wait a minute. This is what we're looking for. This is what they asked for. This is what they asked for, but they did give us another fact that I have not put on that illustration yet. They actually gave us the service level. That is to say, this pale part of the curve, we know exactly how much of the curve that is. That's 90% of the curve, if that's the proper reorder point. I said we're looking for that reorder point. Okay, if we're looking for the reorder point that they're asking for, then 90% of that curve should be to the left, and then the darker shaded portion to the right, that should be exactly 10% of the curve, or as close to 10% of the curve as we can get. All right, so we just really, really wish we knew what that spot was. We really, really wish we knew what that spot was. Okay. We do have some readings here concerning the area of the curve to the left and to the right of a particular point, but it's not for our curve. This is, if you have printed out the note frame, is the second page. This is the standard normal curve. Standard normal curve is just a very particular kind of curve in which it happens that the center is 0 and the standard deviation is 1. Oh, all right. And so what this table is saying is that if you look up any certain number z over here, it is telling you exactly how much is shaded in here. And we wish our curve fit that description exactly, because that is actually what we're looking for. We're looking for 90% of the curve to be this right here. Right, but our curve doesn't fit that exactly. But wait a minute. That factor z looks very familiar to me. You know, generally speaking, if nobody is giving us any advice, I'm going back to the question here about a reorder point, we're left with the formula that a reorder point is your average demand during lead time plus your safety stock, but that's usually described in a formula as being some certain z value times the standard deviation of demand during lead time. And that's not a coincidence. It's that same z value. This is your safety stock. You say, I'm not after safety stock, I'm after the reorder point. True, you're after the reorder point. You almost have everything you need because you know this. This was, you know, we quoted it, that this is that same thing that's down here. That's at 1500. And you actually have this because that's this right here, the 200. What you don't have right now is Z. If you had it, you could drop it in there and we'd be done. We'd have the reorder point, except, wait a minute. I bet we could figure out what it is from this table. I bet we could figure out what it is from this table because this is an exercise some people call using the Z table backwards. I want to know what Z belongs to an area 0.90000, right? 90%. I don't see a 0.90000 in here exactly, but I'm looking for just as close as possible, and this looks pretty close to me. What is this right here? It is an area of 0.8997. You said, huh? Wait a minute, what are you doing? I'm looking inside the Z table, which is telling me the area to the left, which would be the equivalent of the service level, right, in our curve. And I'd been asked to find a reorder point that corresponds to a service level of 90%. So I'm looking in the table for the one number in there that most closely resembles 0.90000, 90%. And I found it. The question is, what Z value does it belong to? Well, trace that first out to the row. There's your first two digits. And then upwards to the column. There is your third digit, or the second decimal place. Then piece it together. If you want 90% to be in here, you want a Z value of 1.2. Then consult here, 8. A Z value of 1.28. Oh, that's the number that's missing. That's the number that would get me this. That's the number I need to finish this. Yeah, 1500 plus 1.28. I got that from the table by finding the one Z value that came the closest to leaving exactly 90% in here. All right, now wait, I need to finish out the arithmetic, right? Times 200. Okay, I figured that out on my calculator, and I get 1,756. So, okay, that's the answer. Because we were asked to find the reorder point that came as close as possible to a 90% service level. If they want to have enough 90% of the time, but are willing to run a stockout risk of 10%, right? Just the opposite. They should reorder water bottles when there are 1,756 bottles left in stock.